Assalamualaikum and hello everyone. We are from Group 9 and we're presenting for the topic Visual Aids for Air Transportation. So here our team member, we have Noor JUHAIDAH, Noor SYAFIQA and also NURSYAMIMI IZZATI. Now, let's first look at visual aids in aviation. Visual aids are tools and systems designed to help both pilots and ground crews see and interpret important information during flight and airport operations. These include things like runway markings, light, sign, and approach indicator. They play a crucial role in improving visibility and ensuring safety, especially during low light or poor weather conditions. Interestingly, even personal items such as sunglasses are considered as visual aids. They help protect the eyes from glare and bright sunlight, allowing pilots to maintain clear and comfortable vision while flying. So, whether it's a system on the runway or something as simple as eyewear, visual aids are essential for safe and effective aviation operation.
So, the first visual aids for air transportation is sunglasses. Pilots use sunglasses to protect their eyes from harmful UV radiation and enhance visual comfort and safety while flying. At high altitudes, UV exposure is much higher than on the ground, and cockpit windows do not fully block UVA rays. Without protection, this exposure can increase the risk of eye conditions such as cataracts, photokeratitis, and macular degeneration. Pilots most commonly use their sunglasses with a grey or brown tint. These tints offer the best balance between protection and visual clarity in flight conditions. Grey tint provide true color perception by reducing overall brightness without distorting colors, making them ideal for maintaining accurate visual references in the cockpit. Brown tint, on the other hand, enhance contrast and depth perception, which can be useful in hazy or cloudy conditions. Next, the most commonly used frame styles will wrap around an aviator. Wrap around frame is a style of eyewear where the lenses and frame curve around the sides of the face. It offers the best coverage by protecting the eyes from sunlight and UV rays entering from the sides, which is useful in the bright, high-altitude cockpit environment. Aviator frames, originally designed for pilots, remain popular due to their large lens area and classic design that provides wide visual coverage. Type of lenses that commonly avoided by pilots are photochromic and polarized lenses. Photochromic lenses darken in response to UV light, but most cockpit windows block UV radiation, preventing lenses from darkening properly. This can result in insufficient glare protection during flight, and polarized lenses only let light through in only one direction. They can cause visual distortion, can block or distort digital displays, LCD screens, and instruments panels, making it difficult to read critical flight information.
A display, navigation display. So if I put my polarized sunglasses here, if I bang a little bit, you see that you won't see anything. So it's strictly forbidden to use these polarized sunglasses on modern day airplanes. Here we go with the Ray-Ban. You see nothing is happening. And finally test for Randolph. They are good as well.
So here we have the head-up display or HUD in aviation. A HUD is a transparent screen that projects critical flight information such as speed, altitude, and heading that right in front of pilot eyes. What makes it so useful is that pilots don't have to look down at the instrument panel. Instead, they can keep their eyes on the sky or the runway, which is especially important during takeoff, landing, or in poor visibility conditions. HUD benefits pilot by reducing the pilot's workload, improve reaction time, and enhance situational awareness. It's designed to make flying safer and more efficient, allowing the pilots to make quicker decisions while maintaining full focus on what's ahead. As for example, when low visibility due to fog happens, the runway normally might be hard to spot until the last moment. But with a HUD, the runway layout is projected onto the screen even before the pilot can see it physically, and the flight path marker shows exactly where the plane is headed. Now we are talking about the head-mounted display (HMD). A HMD is a device worn on the head, like a helmet or visor that displays critical flight information directly in the pilot's line of sight. This allows pilot to access important data without looking down at the traditional cockpit instrument. One of the biggest advantages of HMD is that they provide situational awareness by projecting real-time flight and mission data, such as airspeed, altitude, the horizon line, flight path vector, turn and back indicator, and many more. Next, let's look at the Extended Vision System or EVS. EVS is a technology that helps pilots see better in low visibility conditions such as fog, rain, or darkness. It works by using special sensors, most commonly infrared cameras, to provide a clearer image of the outside environment. And this enhanced view helps pilots identify important features like runways, terrain, and obstacles even when the visibility is poor. By improving what the pilot can see, especially during critical phase like landing, EVS greatly enhances both safety and situational awareness. Other than EVS, we also have Synthetic Vision System SVS. SVS displays a 3D computer-generated image of the area around the aircraft, giving pilots a clear, visual view of their surroundings. It uses a detailed terrain and obstacles database to create this realistic image, so it works even in complete darkness or very poor visibility. With SVS, pilots can clearly see terrain, runways, and nearby airports even when they can't see them with their own eyes. And this system helps improve navigation accuracy and overall safety awareness, especially during challenging conditions like night flying or bad weather.
Ever wonder how student pilot learns to fly safely and confidently? Here we go. It all begins with visual aids, the key tools in air transportation that help pilots to see, understand, and make the right decision. One of the most important tools is the Frasca flight training device. With a 220-degree view, this simulator gives student pilots a real cockpit experience. So, what exactly do student pilots see in the simulator? Let's look at the key visual components included in the Frasca flight training device. There are 3 horizontal lines. Line A, top right. This shows the correct pitch attitude during the initial approach. Line B, white. It represents level wings and help pilots identify the runway aiming point. Line C, bottom right. This indicates the proper pitch for the flare just before touchdown. Then we have the vertical lines. Line D, vertical yellow. This shows the aircraft's longitudinal axis, helping pilots stay aligned with the runway center line. And the smaller vertical yellow lines show how far off-center the aircraft is, helping correct any drift. These visual aids help student pilots understand aircraft positioning and control inputs, especially during crosswind approaches and landings. It's focused their attention on key visual cues during training to improve approach and landing skills. Airports operate 24 hours a day in all weather conditions. Visibility may often be poor due to fog, rain, or nighttime operations, making it challenging for pilots to navigate safely on the ground. To ensure safety and efficiency, airports rely on lighting system as a crucial visual aids. Runway center line lights illuminate the center of the runway to guide aircraft during takeoff and landing. It also enhances visibility in low visibility conditions. Takeoff hold lights. Red lights located along the center line of the runway before the takeoff point. It illuminates red to warn a pilot not to take off because there is another aircraft or vehicle on the runway ahead. Let's say you are a pilot getting ready for takeoff. While moving along the taxiway, a bright red sign suddenly lights up and says, "Stop." What does that mean? That sign is called a variable message sign, and it's an important part of the airport lighting system that keeps everyone safe. Let's find out how it works. As you can see in the photo, on the left, the sign displays a bright red stop command, and on the right, the sign is turned off. These signs use the latest LED technology and are positioned along one or both sides of the runway. They provide a clear, one-way visual command to the pilot. This is especially important in emergency or danger situations where the sign will display the unmistakable word "stop," telling the pilot to stop immediately. Once the situation is clear or safe, the sign turns off automatically. This lets the pilot know that it's safe to proceed and continue taxiing smoothly on the runway. So, the variable message sign is a useful safety tool that helps air traffic control communicate with pilots using clear and simple visual message to avoid accidents on the ground. In summary, visual aids in air transportation are essential for enhancing safety, training, and efficiency by providing clear, instant guidance without solely relying on verbal instructions. They help improve situational awareness and decision-making for pilots and ground crews through tools like flight simulators for pilot training, heads-up display for real-time flight data, sunglasses to reduce glare, and airport lighting systems that guide aircraft during takeoff, landing, and taxiing, especially in low visibility conditions. That's all from us. Thank you, everyone.